Program manager over at NAASIC, and we're Autonomous Systems Group, and we do a lot of UAV work, and we've been working very heavily with NASA on the UAS traffic management system. So why do we need a traffic management system? We have to start registering our drones in December 2015, and to date we have 770,000 drones have already been registered, and compare that to about 320,000 registered manned aircraft, so we're already double the number of manned aircraft in the US. Over 100,000 drones were already registered this year since January, and NASA predicts that in 2020 there will be about 7 million small UAS, and that about 2.6 of those will be commercial. So there will be a lot of hobbyists, but there's going to be a lot of drones in the air. So we definitely need a system. And then the little graphic on the bottom just shows that if you're between 0.55 pounds and under 55 pounds, that's what you have to register at the moment. Those are fairly small compared to what I think we'll be seeing in the future. So this is a graphic from NASA. This is the one they always use to sort of show the different uses of commercial drones. Everything from cargo delivery, which we have the company here, Flirty, in Reno, that's very active in that, but Amazon and Google are also very involved. Search and rescue is something that even our group at NAASIC is working with. We're having a symposium in 2 weeks to bring together first responders and aircraft manufacturers and FAA and so forth to work on that. Infrastructure inspection, here they're showing rail surveillance. That's huge, doing the millions of miles of railroad tracks and power lines and so forth. And then agricultural application, huge. And even out here, wildlife inspection, rangeland inspection, looking for areas that might be prone to forest fires. And then pictures. Of course, we have a lot of people in the U.S. that are using drones for mainly for real estate, but also for sports events and just weddings and whatever. So, and two terms you also see here are persistent and portable, and those are the two types of UTM that are visualized. Persistent would be for areas where you know that there's going to be constant UAS traffic, but portable is for if you're going out and to do rangeland inspection and you need to basically set up an airspace control area on it just for a temporary time. So right now, as of August of last year, we started following the FAA Part 107 rules that govern commercial flights. So right now, it's visual line of sight only under those rules. During daylight, 3 miles weather visibility. You can't fly over persons that are not directly involved in your mission. You have to fly under 400 feet above ground level. Only 1 aircraft per pilot in command, and again, under 55 pounds. Well, you know, if you have to be able to see the UAS, that means it's not very useful for package delivery, rangeland inspection, search and rescue, because honestly, once these small UAS get very far from you, you really can't see them. It doesn't take long to lose sight of one. So moving forward, we want to go to beyond visual line of sight. We want to do night operations. We want to do urban operations. We need to be able to safely fly in more congested areas. And multi-vehicle operations, because if you have to have 1 pilot in command for every aircraft in the air, that's pretty redundant. So we're moving forward with these types of things. So the problem with all these drones in the national airspace is, first of all, at the moment, they don't have ADS-B or transponders, things that will relay their position to people on the ground. We don't know where they are. So that's something that hopefully in the future we'll have our drones all equipped with that type of equipment so that we can monitor them. But we also have widespread deployment of unmanned aircraft will place a huge burden on air traffic control. I'm sure all of you want your air traffic controllers at your local airport focusing on manned aircraft and not on little birds flying in and out of the airspace. And then again, to be really efficient with drones, we need to move into a world of multiple UAVs where there's going to be a lot of traffic in a given area and possibly only 1 person operating multiple aircraft at a time. So we need to be able to manage all of these aircraft in the national airspace. So NASA has been working with the FAA to develop the UAS traffic management system. They want to make the system as autonomous as possible, which means removing people from the system, because it will be much more efficient if it's very autonomous and it can take in all the data and then send data back to the aircraft without having people in the line that actually have to check things. NASA has been partnering with academic researchers and actually hundreds of industry partners to do this. They've wanted to make their testing as diverse as possible. So they brought in not only all these industry partners, but they're testing in areas with different climates, different terrains, different elevations, different population densities, all kinds of aircraft, all the different platforms and ground control stations, and also different mission parameters and goals. They try to test with very realistic either search and rescue, package delivery, infrastructure inspection. Anyway, the scenarios that they come up with are very realistic. So they want to test different platforms, scenarios, locations, to make it so that they've really covered all their bases, because as you know, the US we vary completely in what we're going to be doing with these drones. So the goals of UTM, and these are sort of the far-reaching goals, these are not the things that we've actually been able to do so far, but basically have the infrastructure, yes? Oh, sorry, you're just stretching? Okay, basically have the infrastructure to enable and safely manage widespread use of unmanned aerial systems in low altitude airspace, below 400 feet. And things that are part of UTM that are not all there yet are basically airspace design. Are you flying in the right airspace? You don't want to be near an airport. You don't want to be near sensitive infrastructure. Dynamic geofencing. When have you gone out of the volume that you've created for your flight? What happens if severe weather or high winds suddenly pick up? Is that information going to be transmitted to your system? And it can be through the UTM. Congestion management, so if you have a lot of vehicles. Terrain avoidance, something that we deal with here. Route planning and rerouting if there are changes, if something happened, fire. In fact, the bottom one is contingency management. What happens if there's something that will really affect your flight that you need to know about? And then separation management for high volume areas. And sequencing is really takeoff and landing, so that you have just like you would have with regular air traffic management at an airport, you have to have a sequence when people are taking off and landing and spacing and so forth. So those are all things that UTM would like to solve. So here's a diagram of sort of an ideal UTM system component. There's a lot of diagrams out there that are similar to this. You have your aircraft and your operator. And your operator you want to fly, so you submit a plan to what will be a UAS service supplier. This is something that NASA is really moving toward. That will be like third-party companies that can take your flight plan data and transmit it to the traffic management system. But what they're going to do first is verify that your aircraft is registered, that you are credentialed. They will know something about the capabilities of your aircraft, and by knowing the capabilities of your aircraft, that helps them decide if that mission is appropriate for your aircraft. So you send information to them, they can check to make sure you're credentialed, they can send your plan to this traffic management system, which can then return if there's any constraints on that plan. The traffic management system will be talking basically to the air traffic controllers in the national airspace. And so you're saying to them, this is the plan, this is the route we're going to fly. They're coming back and saying what the state of the national airspace is. They're getting data from up here. This swim data is data on weather, aeronautical information, flight information. So there's a lot of data going on here, but also this supplemental data service provider is something like weather, terrain. So you have other data providers that would be specific to your type of mission. And then also these folks here are talking to public safety. What if you've already got your plan, you know, earthquake, fire, hazard, something, public safety, even if there was a crime in the area, you're getting information from public safety. And then public here, even if there was just maybe an event, a festival, a balloon festival. So there's a lot of information that would come through the service supplier and back to you as the operator. And this is what they're trying to make as autonomous as possible. And so here's just sort of a UTM sequence example. The UAS operator submits your flight plan that has your waypoints, your start and end times, your operator information, and it goes to the UTM through that UAS service supplier. And the USS will check the mission parameters and then and send that to the UTM. And then through the USS, you'll get an approval, yes, you're good to go, a rejection, or possibly changes that you might need to make to your plan based on what's going on in the airspace, weather, all of these dynamic constraints that are changing. And so if the mission is a go, then you can initiate the flight. And then your operation will actually get shared back with people who are regulating that airspace, which is the FAA. And then if a new airspace constraint arises during your mission, that information will come back to you, the operator, and then you may be requested to terminate the mission or reroute. But there's this constant feedback system. And then if there's a failure or a problem, such as you've actually gone out of the volume that you've set up your geofence, maybe because of strong winds or a malfunction, or you've lost link to your ground control station, then the USS will help you with contingency procedures. And so if none of the problems arise, then you can complete your mission successfully. So NAASIC, our group, we've been involved with NASA on the development of this UTM since 2014. This is mainly Dr. Richard Kelly, who is our chief engineer. He actually is the one who developed the client system, and that's the system that actually takes your telemetry data from your GCS and sends it to the UTM server. So the client is the part that you actually have on your laptop, and that's what Richard helped write with his students. And they got his system validated in 2015, and then UNR was one of the first partners at the very onset of this research. Flirty was actually the group that flew for us during that mission, and the flight ops were conducted at Crow's Landing in California, and everything was a success. So that was build one, that was at the very ground level of this. And then, well, before that, Nevada became one of the 6 FAA test sites. The test sites assist the FAA in safe integration of unmanned systems into the national airspace, and there's 5 other test sites scattered about. And we work under the Nevada Institute of Autonomous Systems. They oversee the test site for the state. And we've been assisting them in their mission at the FAA by helping with these UTM flights with NASA. So NAASIC has been involved in all the flights, in basically all the builds so far. And we've been flying at STED. And to something we have at STED that most of the other test sites don't have is we actually built a lab, and the lab has a direct connection to NASA's airspace simulation system, so that as we upload our data into the system, they were actually at NASA Ames, they were seeing what we were doing here through this direct connection that we have with NASA Ames. So we built a lab, actually this is Reno Stead Airport, and this entire wing is actually UNR's. We have a computer lab there, and we also have a workshop for building UAVs. And then this is a photo of Dr. Kelly at the opening of the STED lab, and we actually had Governor Sandoval come out, and then Cami Burkwan, one of the undergraduates who worked on the UTM. So this is what it looks like at STED. So that lab is down here along in this cluster of buildings, and here are the main runways. And then this area out here, sort of under the dark cloud, that's actually where we've been flying. So we, in April, June, August, and October, we were out there with NASA doing test flights. We had ground control stations set up at 5 different places. We had visual observers located in certain places. And we had partner companies come in from all over the country. I think we had something like 10 partner companies come in with all different platforms, different missions. And the idea was for them to get their aircraft in the air, sometimes individually, sometimes multiple, and see how well NASA could track everything in simulation. And we actually had a lot of success. And so here again, April was when we actually had all 6 test sites in the country had 4 aircraft in the air at any given time. It was a huge success. In June, we had just NASA came back, and we flew 2 different we flew their multi-rotor and one of their fixed wings. So it was just NASA in June, but then August and October was when we had like these 10 different partner companies come out at STED, and it was 5 companies at a time, and we did all these various missions. And so you can see what it looks like out at STED. The problem with being out at STED to these missions is it's either really hot, or really cold, or really windy, but it's actually never perfectly pleasant. So we've been out there for every kind of weather. So the future of these UTM operations next year, well, I shouldn't say, this is jumping ahead. They're actually coming back in April and May of this year to do some more testing instead. And we actually have a whole bunch of partner companies again, Flirty and Drone America, and I think even Amazon. We have a bunch of partner companies coming. But skipping ahead, that's going to be more about the TCL2, which is the I always have to pull out my cheat sheet, sorry. Technical capability level is what they call them. But jumping ahead to next year, as they want to make these systems more autonomous and more diverse, they will be including cooperative and uncooperative UAS, which will mimic manned and unmanned operations over moderately populated areas, and then they're eventually going to go into higher density urban areas for much more realistic UAV operations. And even nighttime operations. And this is just, Amazon is very involved. NASA had a UTM conference in 2015 and again in 2016, and some of these bigger companies all have sort of their idea of how to manage the airspace, and so the input's coming in from everyone on how to do these airspace. And this is just Amazon's concept. So it would be below 400 feet, and you'd be going from a rural area that's low risk into more urban areas, and you would have it actually vertically segregated by speed as you get into the very dense urban areas. And then the no-fly zones are the areas around airports with controlled airspace. And that's it. Yes?
What kind of additional costs have been talked about having to go through these third-party companies as the operator instead of directly contacting the government and the airports to get clearance?
That's a very good question, because I think the way these UTMs work is there's going to be a variety of UTMs, whether they're going to be portable or the ones that are actually persistent. So it's not going to be just like one giant UTM, and because they're going to be customizable depending on your mission. But then you will have, I think the reason NASA wants to have these third-party companies, obviously, is because part of this whole thing is economic development, creating new businesses. But I don't know what the costs are going to be or how that subscription is going to work. So I haven't gotten there. Yeah.
When you talk about the communication going back and forth between vehicles,
yeah,
is that using the cellular?
Cellular, yes, that's cellular. Yes. So the UTM basically runs in the cloud, and all of our communications are through cellular.